It's more the money, the opportunities. And yours?
Yeah, I think that's the biggest theme, that when we talk about alloys, it's not just buying that silver ingot and putting it somewhere. No, it's just a tool for you to develop something that on the either way hasn't been there before, or brings a new advantage that hasn't been there before. And there are so many things as we go more to the limit.
Hello and welcome to the Goldcasting podcast. Today we are sharing something very, as we see it, interesting. We are launching a special focus in 2026, meaning alloys. We all use them. They are approximately 50% of a casted part before machining. There's a lot of things happening: trade, politics, developments, new players. We have everything. It's a great and dramatic situation we're looking at, and it will probably not calm down in this year. It will continue for a number of years. So that's my take on alloys. What's your take on alloys, Fabian?
For decades, alloys was basically fixed. Since 1994, the development of the shock tower, the ALSE10 MNMG was the alloy where everything that needed properties was done with. And now with the sustainability, non-heat treatment alloys, cost reduction, we've seen so much dynamic in that field that now every OEM is saying, how can we improve properties? How can we get more scrap into it? What scrap streams are available? How do we adjust our alloys to fit certain applications? So again, it's the alloy landscape getting wider and wider. And I think that is a really good news for the foundry. It's not like one alloy, one product, and spread it all over the world and the cheapest one will get it. No, now you have the real chance with the right alloys, with the right alloy strategy to really get great parts in that are in high volume, in high demand, and in good margins.
Yeah, and you have been working for an alloy producer, so you should know.
Yeah.
Alloys,
yeah.
But the second good news, dear listener, is that yes, we have taken a very good subject, but the second good news is you will not listen to us. Primarily, we have a long, interesting array of people who are experts in different fields when it comes to alloys, from sustainability, from the making and aspects like recycling and all the problems that comes with it. And of course, we cannot have all generic questions for them, but one thing will lead to another. And I can assure you, we already know that these episodes will be highly filled with content for you to take your business decisions. So tune in to us and listen in, but maybe we also should take the opportunity here and now and discuss the questions we are going to highlight during this interview series.
Yeah, absolutely. I think we can start with the first one, an already touch point from the foundry side, that usually they had one melting furnace distributing the alloy to all the die casting machines. That is a picture you won't see coming for the future. I think there's a more diversified portfolio of alloys needed, more flexible melting strategies, but then it's not that you have every foundry in the world as your competition. No, you're getting now with, again, differentiation. So we are specialized in doing the standard alloys, but then also for that application, we have the right alloys and can do that. And now you have a way smaller pool to fish in, and that really makes you stand out.
Yeah, and it kind of increases the entry barrier for any competition that hasn't made the homework, I would say.
Absolutely. Also, when you look now with stain hybrid die cast, when you reduce the silicon content, what's happening to get rid of the two-step heat treatments on ALSE7, many new products are made of that alloy. Casting the alloy is way more difficult than an ALSE10 because it's further away from the eutectic point, larger solidification interval. So you have to design a tool a bit differently. You have to adjust your sound management. You have to adjust your spraying system. All these small little changes are a small shovel in your moat, making it harder to challenge you on that.
Yeah. So this is a question we will definitely highlight. How can you as a foundry take advantage of the knowledge and stick out and do some great business, defending margins, increasing margins, or just become a foundry for the future? But then we also see something else that we are going to discuss with some good people. There's a lot of development programs right now. I see it from our perspective where car manufacturers are trying to find the best balance between dirty scrap, basic scrap, and primary, yet having the properties, but also thinking about sustainability and cost. And you as an old alloy mongler, Fabian, do you think that we are getting threatened by this, the alloy makers?
What do you mean by threatened?
Yeah, they're challenged. I mean, they've been delivering for years and years and years. They got long contracts, and all of a sudden someone is saying, maybe we're buying a couple of thousand tons of something else.
No, I think maybe for some alloy makers, if you're used to doing millions of tons in the same specification, then you might have a challenge. But the smaller ones that are more flexible in alloy compositions, for them it's now the golden time, I think. So again, it's diversified. It's easier to stand out. It's easier to become the preferred supplier, even for some niche alloys with still large application windows. And then I think the biggest competence in that is not where you buy you make your primary aluminum. The key competence in that is then how to buy and where to buy the scrap.
Yeah. Which leads us to the third questions we have in our manuscript here: the scrap market. Where is it going? How is it going? I mean, we hear everything about exports to Asia from Europe and the lack of scrap, and you have to feed a monster with primary and all these things. I think clearing the room and getting the picture is important for all of us, because there's always a lot of rumors. What is true and what is a fact, and who can actually tell us? We know the guy, and the guy will be here for an interview. That we know.
Yeah. Also, with all this discussion is, what are you benchmarking against? What specification do you take, and then what test? So there is so much you can sabotage or so much you can win, and not every application needs the highest grade, and there is a lot of improvements to do. And we've seen it especially with all the gigacastings, how much development they do for the alloy, fighting over 0.05% here and there in certain combinations to get a certain far corner, a better quality, a better flow length. And these are also the effects now we see trickling down into the normal production line.
Yeah, these are important questions. Another thing we will try to put out there with some more facts and insights is this trade politics. We see the tariffs, we see the problem with Rusal and Russian aluminum since the war in Ukraine. We also see the tension between China and other countries. So big players, trade hinders, and believe it or not, their aluminum is a very important token in this political game. And what will it make? And what will happen actually when people are using aluminum as a trade power? Important.
Oh yeah. Also, not just aluminum, all the products in the steps of making aluminum, there is a lot of things going on. And then you see that certain countries are just limited in their supply in aluminum. That's why they are so hard in buying aluminum scrap. And these are things that get more and more critical the more people want to have the scrap. Because when we go back, so especially looking at what have we currently in 20-year-old cars for aluminum, that is not suited to take one-to-one to use it into a structural casting with high properties, high elongations. So you cannot have the same aluminum for the now new application in the same part. That is something where you really need to find sources. And then also comes the discussion who has the right to have that, because if you, for example, take extrusion profiles, take them into casting alloys, then you take up the scrap from another application.
Yeah, like extrusion.
How do you balance that? Because they have the same requirements to import more scrap in their processes.
Exactly. We can talk about this for hours. I think also we are trying to highlight what is what, because when we talk about scrap, most of us think about these beer cans that we throw into the system, right? And maybe once a month we go to the recycling center where we can throw a lot of things. But now we have post-process, post-consumer, and all these things. And we need to iron this out. What is what, actually? And especially, what is true? Can I buy a stamp saying that something is post-process? Or, these are important questions. But then I would like to actually jump into something else that I think is important for the long-term planning of everybody, is the newcomers. We hear about new smelters. We hear about initiatives. We hear about the developments in inert anodes and stuff, making primary, again, a useful source that is not that bad when it comes to carbon dioxide. A lot of rumors, we need to shed light of it.
Also, we have to look into how much volume can you produce, because when you look around, if you have a coal-based power plant powering your aluminium production, you end up with 20-25 kilograms of CO2 per kilo aluminium. If you have something like the best of the best primary you can have at the moment, you're just around 4 kilograms of CO2 per kilo aluminium. And then there is a massive difference in between, and you have to add also that where you have the good and clean energy, there you don't have any bauxite, and then you have an impact on the global traveling routes.
We got to dive into that, right?
Oh yeah.
Yeah. Another questions we have, and we're scheduling interviews, is this CBAM. We were talking so much about CBAM, me and you, Fabian. Is it now 2 years ago?
Yep.
And warning everybody. Have you seen anything about CBAM lately?
I've seen the first companies advertising their CBAM consulting services, but I haven't seen anything that a company is now really working with it, or as now it's 2026, CBAM is active, so you have to be reporting.
Yes, but my question is, since we took off 2 years ago, has the CBAM law been diluted, meaning it doesn't hit that hard, or are people just waking up as the bill is landing on the CFO's desk? This we will iron out with a dear friend of us and really dig into it. And what is CBAM now? And what is believed to be CBAM in a few years when they are adjusting the law?
Also, you have to see how then CBAM acts with certain free trade agreements and all these small things that seem irrelevant or unrelated, but now they're suddenly related when you have products passing these borders. And then we have to discuss, for many purchasing organizations, their main job, especially for the tier ones, is buy casting here, buy casting there, put them together, one screw through, or just weld them together and then ship it on to the OEM. For them, year after year, it was just cheaper price, and now you suddenly have a new cost component. How is it going now? Because we have seen that before CBAM, if it's not a real cost, then we don't care about it.
Exactly.
Now it starts to cost money. Do we see a shift of the purchasing?
Exactly.
I think that will be the hardest thing, to get someone to speak openly about it.
Yeah, but we will do it. We will try out. Maybe we have to bring some cognac to the studio to make people brave, but we have to. That's our responsibility as responsible podcasters, to try to give it to the audience. Another thing I want to dig into, and I'm hoping to place a very interesting guy in the room, is the properties needed. Now we come back to all these gigacastings. And in the beginning, it was double-digit elongations and high strength and all that. I see a tendency that people will weaken the demand for the elongation. And as a matter of fact, I just heard that a certain developer actually just poured aluminum silicon 10, had an elongation of 5-6% in average, made a crash test with a complete vehicle and just passed all tests, meaning having a safe vehicle. If that is true, we have been chasing for this unicorn, and maybe the truth is much, much simpler. So we have to discuss the properties.
To it into how you build a car, because these 10% elongation comes from, you have a lot of small castings and some sheet metal, and you weld it together. So you need really good singular pieces to get an overall good structure. Now when we have larger and larger castings, the casting in the structure takes up so much of the energy, so you can design different. Then we also talk about how you really go for all aluminum vehicles, and then you have to also decide, when you go from steel to aluminum, you can change a lot. You have a lighter vehicle, so you can reduce mass in certain areas, and then when you reduce the mass, the vehicle gets lighter, you don't need the same properties, and then you have a second round, and you can reduce the weight. At a certain point, you can take out a battery box and things like that really have an impact without challenging the performance of the vehicle. But there is so many things you can do by implementing the right alloy and the right design for these alloys.
And then we have crème de la crème. We have something around special alloys too for you, dear listener, where there actually are some business opportunities if you're a foundry. We have a guy coming in and telling us how they are actually solving a number of cooling problems and others. So this is something we look forward very much, because a business is not good just because it's big. If it's big enough, everybody will be there fighting and challenging you. But finding those small pieces where you actually have a good margin and an interesting work is not that stupid. So, special alloys will definitely be a theme here and there. Anyway, as you can feel, we are pretty energized about this. We feel this is not a platform, it's a focus area, 2026. We love to do this, but we will be even greatly more intense in our efforts to service you, dear listener, if you send us your questions. If they are smart, if they are stupid, if they are long-term, short-term, just send it to us and we try to adapt and we try to incorporate it when we are talking to all these experts. So reach out, text us, send an email, smoke signals, whatever do, and then we try to bring it up. And we're most grateful for all comments we can get. Comment on LinkedIn, for example.
Absolutely, yes. I think, especially with that episode, there is so much coming up. Please help us to make it the perfect episode for you. And I think, Staffan, we can start a discussion today and dig a bit deeper. And so what would be your favorite topic in that alloy
when it comes to alloys?
Exactly.
Oh, I must admit that I'm a cynical guy. I got 10 years of my retirement, so it's the money in it. How to get better business, better margins, how to win the market, how to conquer the market in some kind of perspective. So if it's about the special alloys, the thermal management, if it's about making your own alloy at your machine and bypassing everybody by reducing smelting cost, be my guest. But it's probably not the metallurgy side of it. It's more the money, the opportunities. And yours?
Yeah, I think that's the biggest theme, that when we talk about alloys, it's not just buying that silver ingot and putting it somewhere. No, it's just a tool for you to develop something that on the either way hasn't been there before, or brings a new advantage that hasn't been there before. And there are so many things as we go more to the limit. It seems in electronics that we get more and more powerful electronics that have to be cooled. And for certain applications, you can put a water cooling on that, sure. But when the aluminum housing, which contacts the chip and takes the heat into the water cooling system, is the limiting factor, it doesn't matter what kind of cooling you have. You need a different alloy for the housing. And with these small changes, then you have the good castability to the right wall thickness. You need the weldability. And that's just one application. Then we also touch base on the gigacastings, where you need the immense long flow length, a good recombination that when melt fronts meet at the end of the filling, that they get flushed out and you still have a good part in there that you can, again, weld to something else or hold up in a crash.
Yeah, these things are interesting. I have another topic that I think is interesting. And believe me, I haven't been eating some strange mushrooms or freeze my brain to zero here in the cold Sweden. But another thing, I'm a strong believer that we have seen the peak of car production as we know it. And as you know, you heard me saying this many times now, that we will see a more fragmented means of mass transportation. Before we had trucks, buses, and personal vehicles, right? Now you have self-driving taxis, voice, two-wheelers in every sort. You got trikes, and this is exploding. But also what's exploding is on the side is also the support system for transportation, meaning all the server halls that will take care of the ADAS systems. You know, the self-driving. You have the AI. When we sit in our self-driving car, we're using our phones and asking a bunch of questions. And all of a sudden you have this cooling problem. All of a sudden you have charging stations.
Same for the charging stations.
Yeah, charging stations. You have a total new infrastructure to be built. And what I'm saying is that the way we have been selling castings to the car industry is also rapidly changing. And in this, the alloys is a key thing.
Also, when we talk about car industry, I think that is way too short. When we look at, for example, India with the two-wheeler industry, that is so massive, you cannot overlook that.
22 million vehicles.
That is a massive amount. And for them is also that you cannot have a steel frame welded together by hand.
No, takes too long time.
There is also lightweighting, electrification going on. And why not use aluminum castings in that? And spoiler, they're already using quite a lot of castings in them.
Yeah, they do. And more it will be. And so what am I trying to say? I think we see a paradigm shift. I mean, even a skateboard is a mean of mass transportation. And it has two casted trucks. They are called trucks, the thing that holds the wheels, That's two castings. And if you start to think about this and how it looks now and how it looked 20 years ago, maybe it's not that certain that your car will look like a car in 20 years. And 20 years is not that long time when it comes to heavy investment in casting industry. So the alloys is a key player in this game to reach the properties, to help the designers, and to win the business. And this is deeply philosophical now, but I see the trend,
Absolutely. And also when we talk about properties, we're not just talking about strength elongation. There are so many more properties that are relevant for certain applications, like the thermal conductivity. For some, it's the electrical conductivity. For some, it's a shielding property. For some, it has to be braceable. So there is so many views on alloys, on what they can do, what they can bring to applications. And that's the fascinating thing.
Yeah, but you know what? In all these fancy things with topology optimization and casting simulations and all the high tech, which we need for making these things, I bet you when I retire 10 years from now, hopefully sooner, that the guys that are making most money will be the scrap dealers.
Yeah.
Simple as that. Reason is...
I think that's always, if that's the question of supply and demand, and we already know that the supply is quite limited of good scrap, and if you have the contracts to secure your scrap streams, you are the one that everybody wants to talk to and do business with.
Yeah, but you think, it's not considered being that sexy, being the scrap dealer. People want to do the flashy things, the gigacasting, the simulation, the nice stuff, the cool stuff, the high-tech stuff. But if you look at the scrap market of aluminum and compare it with the steel guys that have been so much better in sorting different steels. In 50 years they have been doing it. They have a total different distribution. So people that can stick out and actually find a position on this market and find some sources and take some risks. I mean, we have a beautiful example here in Sweden, Stena Aluminum. They're making alloys, you might think. But that's 10% of what they do. The rest, 90%, is actually recycling. Everything. Water, not water, but glass, aluminum, steel, copper, whatever you can think of. Stena Aluminum has a super network. Guess what? They will be a part of this.
Also, let me defend our industry. Steel has a way better standing in the recycling, but there's also the physics on their side. For example, if you put in the oxygen lands to take out all the scrap, the iron stays in. If you would do the same process in aluminium, all that what you want to have out stays in and the aluminium goes. So getting impurities out of aluminium is a massive challenge and nearly impossible to do. And that's way easier for the steel guys, so that's why they are using way more scrap. Otherwise, they would have to cool their processes. Now they take scrap as ice cube.
Yeah, but 1994, I did my exam work at university, and I did it in a steel plant, a stainless steel plant. And my goodness, we had like 15 different fractions, and sometimes we had pieces of tanks coming in because of the molybdenum content, and everything was so sorted, So it was so easy for us to actually boil a specific type of stainless steel. I worked for Avesta Sheffield that summer. Sweden was a development country by definition, It was hot like crazy with a high inflation, and we have a damn good football team. We took the bronze medal in the World Championship that year.
I think that's
get a little bit carried away there.
But come well from some people.
what do you know? Sometimes you stick out. Anyway, dear listener, let's wrap this up. We have a gazillion of good questions. We will try to focus on the ones you have heard, the ones that will affect you now and in 5 years and maybe also in 10 years. We will do our utmost to see to it so you don't need to listen to us. We will interview interesting people. So join us and send your questions. So we look forward to meet you.
That's perfect. So don't forget to subscribe to the podcast that you don't miss the episodes. And then see you in the upcoming podcasts.
Yep. See you. Hej då.
Bye.
Auf Wiedersehen. Bye.